Hi pre-calc, welcome back. This is video 4. I'm gonna try to move through this one a little bit faster since I already laid the groundwork. So we're looking for, in this video I'm going to show you the inverse of cosine. So let's just start with the regular cosine. So regular cosine, the domain goes on and on and on, right? It's all real numbers, and the range will oscillate between -1 and 1. But to find an inverse, it has to pass both the vertical and the horizontal line test. So this fails the horizontal line test, which means in its current form, it does not have an inverse. So we're going to segment it so that segment has an inverse. But that segment, we're also going to agree all the way around the world what that segment is. So again, there's many ways to cut this function to make it 1-to-1, but we're all going to agree around the world what the cut is. And the cut around the world that we use for the inverse to find that we will create the inverse off of will be this cut right here. So I'm now just restricting the cosine to this little piece, and this little piece passes both the vertical and the horizontal. So the domain of that piece is from 0 to pi, and the range of that piece is still from -1 to 1. Okay, so that's the really important part right there, because the inverse is going to have the domain and range swapped. Okay, so we'll come back to that in a moment. Let's also algebraically find the inverse of the cosine. So if you remember from the last video and from when we learned inverses, right, you have to swap x and y. That's how you make an inverse. So right now we're making the inverse. So the cosine's the original function. We're now making the inverse. Now I've got to isolate the y. So to do that, you're going to put on both sides something called the arc cosine. Arc cosine of cosine y. The arc cosine and the cosine cancel. Okay, so this is the inverse function of the cosine. I don't think I mentioned this in the other video, so I want to stress it now. And let me see if I can just find the ditto. Yeah, I can. Okay. I want to stress it now because this word right here is quite long, and for a calculator, the calculator can't hold like such a big word like this. So I just want you to be aware that there's also a shorthand way to say this. And the shorthand is quite terrible because this looks like reciprocal, but it's actually not. This is red arc cosine. Believe it or not, this is actually red arc cosine, and on your calculator you will see this notation because it's very tiny. It can fit above a key versus this notation. And let me just stress that then from the other videos I did, the arc sine can also be written as this. And again, as weird as it seems, this is actually said out loud, arc sine. So if you just saw only this thing here, you would say arc sine. Right, so there's two ways to write the arc. Actually say it out like this or shorthand it like this. Right, so let's now go over the domain and the range of the arc sine, which is the really big piece of this lecture. It's the part that I'm trying to stress. It's what you have to walk away with, these domain and range restrictions, because arcs are very, they're very particular what their domain and range is. They're not just anything, and you have to stay within those particular requirements. So remember, the domain and range swap. So the domain of the cosine becomes the range of the arc cosine, and the range of the arc cosine becomes, and the range of the cosine becomes the domain of its inverse. Right, because the domain and range swap. So like I've been trying to stress, if you're looking at an arc, arcs equal angles. So that's why the range of an arc is an angle, because arcs output angles. They take in the ratio of the sides, but they output angles. Okay, so the range or the output can go from 0 to pi. It can't use quadrant 3. You can't use quadrant 4. You can use all the, for the unit circle, you can use 0, pi over 2, and 180. And you can, of course, use your 30, 60, 45 reference angles in these two quadrants. The cosine is positive in quadrant 1. The cosine is negative in quadrant 2. Just like I was trying to stress that for this arc sine, you have to know where they're positive and negative. Same with the arc cosine. So this really right here, this is what I'm trying to stress. All the other stuff is me just explaining how I got here, but this is what is most important. These things that I'm circling, this is everything. And students that get this, they can rock this out. And this is like I said, this is a really weird and difficult section, but I'm trying to be really clear on what you need to take away. And this is it. These restrictions, why do we have them? Why are they happening? And what are they? That kind of thing. All right, so now let's try to solve the problems. And again, for a lot of us, rewriting it makes it a lot easier, but you don't have to rewrite it if you can see it. It's saying what angle makes the cosine of 1, right? Arcs equal angles. And again, if you want to rewrite it, that's fine, but your answer has to stay within what an arc can output. An arc can only output in between 0 and pi, so you got to be really careful you stay within there. So within the constraints that I'm allowed to use, the only place where the cosine can do that would be right here at an angle of 0. So theta is going to have to equal to 0. You can say that in radians or degrees, it doesn't matter. But that is, so the arc cosine of 1 equals to 0. All right, now here, you can leave it like this and just know that these are the sides, right? If it's an arc cosine, then the side has to be the adjacent over the hypotenuse. So what angle gives you this adjacent over this hypotenuse? And you have to also notice that it's positive, right? Because the plus and minuses matter. I'm just going to rewrite this for people who, it's just easier. A lot of times our brains recognize patterns. So if I rewrite things, it just helps. Your brain can go into the filing system and go, oh, okay, I recognize that now. Versus just feeling like, what the heck is that? All right, so again, for the arc cosine, you cannot use quadrant 3 or 4. Since this is positive, this is so critical here. Since it's positive, that tells you you're in quadrant 1. If this was negative, it would tell you you're in quadrant 2. That's why the plus and minus are important. If it's positive, you're in quadrant 1. If it's negative, you're in quadrant 2. Okay, so again, the sides are the adjacent over the hypotenuse. Adjacent is 1, hypotenuse is 2. Sorry, put that in the wrong spot. Adjacent is 1, hypotenuse is 2. So that means that the opposite is radical 3, because that's the 30, 60, 90. So I'm across from the radical 3, which larger, if you're across from the larger leg, you have to be the larger angle, right? The larger leg corresponds with the larger angle, the smaller leg corresponds with the smaller angle. So I have to be across from 60 degrees. In this one, I can be in standard form, because if it starts at 0, you can rotate in standard position. Okay, so you can give your answer in degrees. If you want to say it in degrees, you're going to say 60. I like to do mine in radians, so it's just up to you. I'm not going to give you a hard time. Your book will be in radians for this stuff, but this is fine. Okay, let's do one more of these. I can see I'm already over to, I don't want to make this video too long, so I'll wrap this one up after this. Alright, so another arc cosine. So the minute I see arc cosine, I think, oh, no quadrant 3, no quadrant 4, that's out. Okay, your SOL on those quadrants. Let me rewrite it for those of you whose brains like it better like this. Alright, so when you look at this, this is giving you the two parts of the triangle. It's asking you what angle makes that true. So since this is negative, that actually means now that you're in quadrant 2, right? Because the cosine, the output of that's going to be negative in quadrant 2. So So that part tells me I'm in quadrant 2. This gives me, excuse me. This gives me the adjacent over the hypotenuse. So the adjacent is 1. The hypotenuse is radical 2. So the other side must be a 1. So it's my 45, 45, 90. Okay, now be careful how you write the answer. If you tell me the answer is 45 degrees, I'm going to go, oh, you're in quadrant 1? And you're going to go, no, I'm in quadrant 2. I'm going to say, well, okay, well, you got to give me an answer or an angle that will put me in quadrant 2. So you've got to make sure if you fall into quadrant 2 that you actually make sure your final answer, it falls into quadrant 2. 45 in this case is actually just a reference angle. So now I have to figure out this angle that's going to get me there. So do you think you can figure out how to do it? You're going to do, you didn't make it to 180, right? You're 45 degrees short of 180. So that means that you have to be at an angle of 135. So now if you say to me, my answer is 135 degrees, I go, oh, okay, you're in quadrant 2, right? And you go, yeah, I'm in quadrant 2. So then we agree. Let me also just do this in radians because I really want you, those of you going up the math ladder, I want you to be really comfortable being in both units for degrees. Sorry, for angles. Oh gosh. Okay, so in radians, this is pi over 4, so it would be pi minus pi over 4, which is 3 pi over 4. So in radians, that is the equivalent answer in the other format. Okay, let me end this video here, and I'll pick up again with the arc cosine in a moment. Catch you soon. Bye.